Hey guys, today I'm going to continue the math portion of this preparing for the ACT test. You see here it's got dates 2023, 2024, but this same ACT test that's out there available for free from the ACT, again, it's called Preparing for the ACT. You can just do Google search within a year. It's been in use by the ACT for the last 3 years or so. So if you do a Google search for like Preparing for the ACT 2022, it's going to be this same test, I think, 2023, 2024. And then in early 2025, they're going to be releasing the new ACT with the changes or what they call enhancements for whatever reason. But today what I want to do is continue what I started last time, which is the math test in here. So last time in another video, and I'll link to that below, I went through the math portion of this test, numbers 1 through 20. And today I want to do numbers 21 through 40. And then sometime later, I'll do numbers 41 through 60. So again, I'm going to be going at not the pace of a student who should be taking this test on test day, because I'm going to be stopping and explaining everything, maybe different ways to solve certain problems. So again, the purpose of this is not to mimic how fast a student should go, it's to teach. So let's get started with number 21. Sorry for all the scribbling, that's my markings from answering numbers 1 through 20, but let's zoom in a little on number 21. In the figure below, A, B, C, and D lie on the circle centered at O. Which of the following does not appear in the figure? So our focus in this figure, obviously, if you look at the answer choices, are these two triangles. We have ABO on the left over here, and then triangle DCO on the right over there. So we have to, well, essentially eliminate right answers and find the one type of triangle that is not present in this figure. So let's start with A. A says acute triangle. An acute triangle is one where all the angles are less than 60 degrees. So if you look at the angle on the left, the ABO triangle, we know that this angle right here is 60. It tells us that. But because these two side lengths are the same, they're both the radius of this circle, we know that these two angles are also the same. And that means that all three of these angles, if the three angles in a triangle add up to 180 degrees, all three of those must be 60 degrees. That makes this an acute triangle, but it also makes it an equilateral triangle. An equilateral triangle is a triangle with three angles that are the same. In other words, 60 degrees. So that's how we know that B is also a triangle that appears in this figure. I don't know why I circled them. I guess I could cross them off, but we know it's neither of those two. Letter C says an isosceles triangle. An isosceles triangle is a triangle where two of the side lengths are the same. So a triangle like this, if this was 10 and this was 10 and this was 8, that would be an example of an isosceles triangle. Well, on the triangle on the right, the DCO triangle, we have one angle that's 90 degrees, and then we have these two angles that are the same, and that means, these two side lengths that are the same, and that means that these two angles right here, the OCD and the ODC on this other side, these two angles are going to be the same. And, well, I don't know if it really matters that much about the angles, but nevertheless, these two side lengths are the same. Oh, it does. Well, it matters about the angles in this way. These two side lengths are the same, the DO and the OC, the two radiuses there. We know that. And those two angles are the same, but because this is a 90-degree triangle or a 90-degree angle right there, that means that these two angles are both going to be 45 degrees. In other words, it's not an equilateral triangle. So that means this is an isosceles triangle. Two of the side lengths are the same. One is different. You know, if this one's 8, for example, and this one was 8, this one down here would be something like, oh, I don't know, 12 or something. It's not, but, you know, it'd be something like that. So that's why it's not C either. A right triangle is a triangle where, well, there's one triangle with a right angle. We know that's true of this triangle, even though I kind of darkened it. So we know it's not D either, and that's why the answer is E, at least by process of elimination. But the question now is like, what is a scalene triangle? So I don't know if that's really a term. I don't know if that's really a term that you come across in math class too often. But a scalene triangle is one where the three side lengths are all different. So it'd be like, you know, that, that, or something. I don't know. Like if that was 4 and that was 6, I don't know what this longer one would be, but it would be longer than, let's call it 11. I don't know, whatever. But that would be an example of a scalene triangle where we have these three side lengths that are all different. And that's how I know number 21 is E, scalene. Okay, number 22. What is the slope of a line in the standard XY coordinate plane that is parallel to x plus 5y equals 9? Okay, well, first of all, I've never seen a math question that doesn't use the standard XY coordinate plane. And is there some other kind of coordinate plane, XY, that I need to know about? I'm not totally sure. Okay, whatever. That's just a tangent. But here we go. What is the slope of this line if we've got this line over here? Okay, so first of all, we need to put this equation into slope-intercept form. Slope-intercept form, y equals mx plus b. That's an equation that you just 100% have to know, and you have to know how to work with it as well. That's why in my math book, the ACD Math System, or my bigger book, the ACD System, math that has to do with this formula, what I call the lines lesson, is one of the lessons that you have to know, okay? So if you are looking at this formula, we need to get this equation into this form and then work with it from there. Because looking a little bit down the line, two lines that are parallel, like, you know, we're told that we're looking for the slope of a line that's parallel to this one. Two lines that are parallel have the same slope, and this is slope right here. So in that case, if we get this into slope-intercept form, then we're going to find the m, and we're going to find the slope of the line that's parallel to this one. So here we go. So we have x plus 5y equals 9. I'll rewrite that right here. Let's isolate the y on the left. So let's subtract x from both sides. We're going to have 5y equals negative x plus 9. Okay, and then we need the y by itself. So to get something in slope-intercept form, you have to isolate the y by itself on the left. Okay, you can't have 5y or something like that. So we have to divide every term by 5. We're going to end up with y equals negative 1/5 x plus 9/5. Okay, but the most important part for this question is the slope. We know our slope, if we get into slope-intercept form, is this term right here, the negative 1/5. If it's negative 1/5 and we're looking for the slope of a line that's parallel to this one, they're going to have the same slope because they're parallel. And that's how I know the answer number 22 is G, negative 1/5. 23, given y equals x over x minus 1 and x is greater than 1, which of the following is a possible value of y? And then we have these 5 choices. So I'm guessing that, you know, maybe some people out there can take this equation, can just think about it and maybe get the right answer. And that's good. But I want to use a strategy called picking numbers. And picking numbers, if you remember, I probably covered it in numbers 1 through 20. I've got a lesson on that in my book, in ACD Math Step 2. But picking numbers just means making this question more real by choosing a value for the variable x, okay? And then plugging into the equation and getting a real number. So for example, we're told that x is defined by greater than 1. So x could be 2, 3, 4, 5, 6, 7, whatever. It could be anything greater than 1. And then I can tell by the answer choices, you know, if I get an answer choice that's like, or if I get an answer, if I plug in x, if I get an answer that's like negative 1.6 or something, I know that the answer is going to be A because that's between 1, it's greater than negative 1. If I get an answer choice that's like 0.48 or something, then I know that D is going to be an option, right? That's probably going to be my right answer because it's between 0 and 1, right? It's a decimal less than 1. So let's pick a number for x. Let's just say x equals 4. I'm just going to pick that one randomly. I'm going to plug it into the original equation, and then I'm going to see what value I get. So y equals 4, right? Because I'm plugging in x equals 4 over 4 minus 1, right? Because on the denominator is x minus 1. Well, that equals 4 over 3. If I put that in my calculator or whatever, I see that this is going to equal 1.33 or 1 1/3. Well, looking at the answer choices, there's one option that's greater than 1 in a positive direction, and that's how I know 23 is E. If I plug in any value for x greater than 1, so x equals 10, well, you can see that, like, I don't know, it's going to be a value greater than 1, or x equals 1.1, you know, something like that. It doesn't have to be an integer, but whatever. I think you get the point. That's why 23 is E. Number 24. The set of all positive integers that are divisible by both 15 and 35 is infinite. What is the least positive integer in this set? Okay, so I can see how a lot of students would probably immediately think, wow, 5 goes into 15 and it goes into 35, so the answer must be F, 5. But the question isn't looking for a factor or a least common factor or the factors of 15 and 35, meaning the numbers that go into those two numbers or numbers that they both share. Instead, it's looking for a multiple. It doesn't use the word multiple in here, but it's looking for the least common multiple, meaning it gives the definition, the smallest number that's divisible by both 15 and 35. In other words, the smallest number that 15 and 35 both go into. Okay, well, 15 and 35, neither of those goes into 5, Neither of those goes into 50. That's just the two of them added together. Let's see if these two numbers go into 105. So if I do 105, divided by 15, I get 7. If I do 105 divided by 35, I'm going to get 3. And that's how I know that number 24 is actually H, 105. 105 is the smallest number that 15 and 35 both go into. 25. In triangle ABC shown below, the measure of angle A is 58 degrees. They've marked that on our figure for us. And AB equals squiggly AC. What is the measure of angle C? What they're hoping is that a student in this question is going to see this symbol right here and get confused and guess and not know what that is and move on. But hopefully, you can make maybe at least a smart guess as to what it means because it's got an equal sign in it, huh? So in some kind of a way, this question is trying to tell you that segment AB is equal to segment AC. As a side note, this symbol means congruent. Congruent is a symbol that can be used for more than just line segments. It can be used for shapes and things. But here it's basically saying that AB, that segment, is congruent with AC. It means they're the same length, okay? So here let's see where these two segments are. So here's AB and here's AC. So what this is saying is that if AB has a length of 10, then, come on, I want to mark on that. There we go. If AB has a length of 10, then AC also has a length of 10, okay? So if we know that A is 58 degrees and these two side lengths are the same, and we already talked about this with number, 21, with the different triangles in there, that means that these two angles have to be the same, okay? This one, which is ABC, and this one, which is ACB, those two have to be the same. So if the three angles in a triangle add to 180, let's take 180, let's subtract off the angle we know, which is 58 degrees, and that leaves us with 122 degrees left between these two angles, and we know they're the same. So 122 degrees divided by 2 is going to give us the angle measure for each of these, and that's 61 degrees. That's how I know number 25 is D, 61 degrees. 26. About 1.48 times 10 to the 8th square kilometers of Earth's surface is land. The rest, about 3.63 times 10 to the 8th square kilometers, is water. If a returning space capsule lands at a random point on Earth's surface, which of the following is the best estimate of the probability that the space capsule will land in water? I think I remember seeing something about this in the news not long ago where I think it was a Chinese space capsule was just going to land somewhere random. Okay, whatever. So here we go. So which of the following is the best estimate of the probability the capsule will land in water? So what we need, of course, is the amount of square kilometers in water divided by the square kilometers of the Earth as a whole, okay? Or land plus water. So water divided by land plus water. What they're hoping is that students will get confused or get messed up because of these symbols right here, times 10 to the 8th, times 10 to the 8th. But if you think about it, we really don't need that part of these numbers, the 1.48 times 10 to the 8th, the 3.63 times 10 to the 8th. We really don't need those parts of it because think about it like this. What we need is water, or the amount of water, relative to the amount of land plus water. And whether or not there's a million decimal points or a million zeros following these numbers, or just 8 of them, or none of them, that relation or that comparison is going to be the same. It's kind of like this. If I have 100 of something, right, and I'm trying to compare that to, 120 of something, well, that relationship, how they compare to each other, mathematically is the same as if I have 10 of something and 12 of something, right? Or if I have 1 of something and 1.2 of something, okay? So I'm just moving decimal points, at this point, and these relationships are basically the same, okay? So that being said, let's actually set up the math and solve this problem. And I'm going to leave off the times 10 to the 8th because I don't need that many zeros after here to get that relationship correct. So there's 3.63, let's imagine a tiny Earth, 3.63 square kilometers of land, okay? And then on the bottom, I need land plus, that's water. That's what I need on the top is water. So 3.63 square kilometers of water. On the bottom, I need the 1.48 of land plus the 3.63 of water, and that's going to give me the probability that this capsule is going to land in water. So if I go to my calculator, 3.63 divided by, in parentheses, 1.48 plus 3.63, that's going to equal 0.71 or 71%. and that's how I know the answer is G. You know, my first inclination with this question actually was, isn't the Earth a little less than 75% water? That was like my first thought when I read this question. And if you can think like that, I guess, and know that the answer then is going to be G, that would be good. You know, hopefully just based on looking at this question, you know, that there's like what, a little, like, I don't know, more than 2 times as much water as there is land, or whatever this math works out to be. Hopefully, if you're going to make a good guess, it's going to be in the upper range, not in the lower range. But let's move on to 27. On the first 7 statistics tests of the semester, Jamal scored 61, 76, 79, 80, 80, 84, and 91. The mean, median, and mode of his scores were 79, 80, and 80, respectively. On the 8th statistics test, Jamal scored 90. How do the mean, median, and mode of all 8 of his scores compare to the mean, median, and mode of his first 7 scores? Like, I've been doing this a long time. I'm guaranteeing that probably 75% of students are going to get this question wrong. And it's not because they are too dumb to remember what mean, median, and mode means. It might be a number of things. It might be first that actually these are terms, mean, median, and mode, that you haven't worked with since like 8th grade. That's actually possible. Another possibility is just that this question is really long, and long questions tend to be missed a lot. And actually, in my research of old ACT math tests, I was pretty surprised at how often mean, median, mode, and then there's a 4th term, range, that goes with numbers like this, how often these terms are used on the ACT. So much so, like I mentioned in my book, I've got a whole lesson on mean, median, mode, and range because it comes up often. And that lesson is in the ACT math that you have to know for every test. So what I noticed first about this is that they tell us what the mean, the median, and the mode are of these first 7 tests. They're given right here. Like this is, I guess I'll write them again. The first mean is 70, that's the average. The first median is 80, which is the middle term. And the first mode is also 80, which is the number that appears the most. So mean is the average, median is the number in the middle, mode is the number that appears the most. So there's 2 80s, huh? Whoops, I got the eraser on. There's 2 80s, and that's how I know that the mode is 80. And another thing I noticed is that they kind of do us a favor because they give us these numbers in order from smallest to biggest, okay? 61 up to 91, and that you have to put numbers in those orders in order to find things like the median of a set of numbers. Okay, so that's good, but then we get this 8th test that gets put in there. It's a score of 90. And so then the question says, how do the mean, median, and mode of his 8 scores compare to the mean, median, mode of his first 7 scores? Okay, well, I don't have to pull out my calculator and recalculate the average, okay, or recalculate anything to get this question correct. Here's the first thing I'm going to think about is, which of these 3 is the easiest mean, median, or mode to determine a change in if I added a new score? And to me, the easiest one to think about is mode. Because again, mode just means the number that appears the most. We've got 2 80s in the initial list of 7 tests. Okay, we already identified those right here. Well, if I throw a score of 90 in here, that's not going to change the mode at all, right? Like I could put in a 90, a 93, a 98. I could add in a bunch of test scores as long as they're unique in the list and don't duplicate any other score. Then I know that, well, the mode is not going to change because I have 2 80s. So there's not a 90 in this list already, so the mode's not going to change. So I know the mode is going to be equal. So if I look at the answer choices down here, there's only 2 answer choices that have the mode being equal, and that's C and E, huh? So I'm going to eliminate A, B, and, whoops, not E. I just said we're not going to eliminate E, and D, okay? Because those 3 have greater as the mode, but that's not true. So it's going to be C or it's going to be E. The second easiest of these to calculate or figure out with a change like adding in a new test score is going to be the median. Okay, so let's look at the original list. The median just means the term in the middle. So in the original list, we have 7 scores. When you have an odd number of scores like that, the median term is easy to find because you're going to have, out of 7, you're going to have a middle term, then you have 3 that are lower and 3 that are higher. Okay, so in our original list, forget that I added 90 in there, we have 61, 76, 79, 80, 80, 84, 91. So this term right here, this 80, is the median because I have 3 scores to the left and I have 3 scores to the right. Okay, 3 scores greater, and I don't know why it won't write right there, and 3 scores smaller. Okay, So if this 80 is the median, the question is when I add in this 90, does the median change? So I'm going to erase all that. Okay, so when I add in this 90, let's pretend we're working with a list that has 90 in there now. I'm going to write it, I guess, like right there. I'm just going to squeeze it in there where the word and is. So now I'm adding in the score of 90. Okay, what happens to the median? Well, now we don't really have a true middle term. In other words, I've got like 4 to the left and 4 to the right now, and the median is right between these two numbers. Okay, like right in the middle between those two 80s. If this was two different numbers, like if it was 4 and 5, well, their median is their average, and their average is 4.5. That would be the median. Even if it doesn't show up in the list, it's just the average of the two middle terms if you have an even number of terms. Okay, well, that being said, look, the median here is going to fall with our 90 in there. It's going to fall between two 80s, and the average is going to be 80. You with me? Because 80 plus 80 divided by 2 is 80. So our median doesn't change either. So that means it's not going to be C either, because this says that the median is greater, but that's not true. So that eliminates all these other choices, and that's how I know 27 is E. Okay, 28. The solid rectangular prism shown below was built by alternating congruent black cubes and white cubes, such that two cubes of the same color have at most one edge touching. What is the total number of white cubes that were used to build the prism? Okay, in other words, there's an equal number of white and black cubes in this prism. In other words, if I can find the volume of this prism, then that's going to tell me the number of cubes that are in it. Okay, because a cube, right, it has the same, let's just say that they all have a side length of 1, 1, 1, 1 all over the place. If I find the volume, that's going to tell me the number of cubes, okay? And then if I divide that number by 2, it's going to give me the number of white cubes, right? Because in this prism, it's the same number of white cubes and black cubes. So let's count the length, the width, and the height of this cube, and then that's going to tell us or give us what we need for the volume. So we've got 1, 2, 3, 4, 5, 6, 7, right on the bottom. If it's it doesn't say it's necessarily a cube, so let's see. So in the height, we've got 1, 2, 3, 4, 5, 6. Yeah, it's not a cube, but it's got a height of 6, and then it's got a depth or a length or whatever you want to call it of 1, 2, 3, 4, 5 of 5. So to find the volume of this figure or rectangular prism, I would multiply these three terms, the height, the width, and the length. We can call this the height, I guess, the width, and the length. It doesn't really matter. So I'll put that in my calculator, 6 times 7 times 5, and hit equals, and it's going to give me a value of 210. So in other words, there's 210 little cubes in this prism. So that's the black plus the white ones. So if I take 210 and divide it by 2 or cut it in half, I'm going to get a value of 105. That tells me there's 105 white little cubes in this prism. That's why 28 is H. 29. One side of square ABCD has a length of 12 meters. I'm going to go ahead and draw that. So here's ABCD. I don't know if I need to, write ABCD on there, but it's got a length of 12. So here's our square. Okay, it has a length of 12. A certain rectangle whose area is equal to the area of ABCD has a width of 8. So we'll just call that 8. What is the length in meters of the rectangle? Okay, so it's saying that these two have the same area, So a certain rectangle's area is equal to that of ABCD. So first we need to find the area of this square. This is square ABCD, and then here's our rectangle. So in other words, once we find the area of this square, we can set up a little equation to find our missing length over here of this rectangle. So the area of this square, of course, is 12 times 12, which equals 144, okay? So now over here, the area of this rectangle is 8 times L equals 144, right? And because we know that these two areas are the same, according to the question, so 8L equals 144. If we divide both sides by 8, we're going to isolate the L. So 144 divided by 8 equals 18. So L equals 18. And that's how I know 29 is C, 18. Number 30. The average of a list of 4 numbers is 92. A new list of 4 numbers has the same first 3 numbers as the original list, but the 4th number in the original list is 40, and the 4th number in the new list is 48. What is the average of this new list of numbers? Okay, this question on the surface seems like impossible. Like I'm guessing the average student is going to be rereading this question like 3 times and just guessing, okay? So I want to simplify this as much as I can. So we have these 2 lists of numbers, okay? In the first 3, they're all the same. So I'm just going to call this X. X, 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 that's the first list. And then here's our second list. Okay, these numbers are all the same. And their average, I'll just draw an arrow. Average, the first one is 92, and we need to know the average of the second one. Okay, this is what we're looking for, is question mark. In the first list, this fourth number is 40. Okay, in the second list, they tell us that the fourth number is 48. Now, what they don't need us to do, but what a lot of students are going to try to do, is figure out, based on this average being 92 in the first list, what these other three numbers could possibly be. And a lot of students are going to spend time doing that. It would be okay to do that, I guess, but it would be a waste of time. Here's what we know about this second list. We have 8 more. Okay? 8 is being added into this average of, or into these lists of numbers, because these numbers are all set. Whatever it is, 100, 100, 100, whatever it is. And then we have 40. And then we have the same 3 numbers. So far, these two are the same through these 6 numbers here. But then this number is just bigger by 8. And that means that this whole list is just bigger by 8. If it's bigger by 8, and there's 4 terms in the list, it's bigger by 2 per number. Okay? There's 4 numbers in the list. 1, 2, 3, 4. If this one is bigger by 8, the second list, that means it's bigger by 2 per number. 8 more, 4 numbers, divide those, you get 2 per number, okay? If the second list is bigger by 2 per number, then that means that the average is going up by 2. If the average of the original list is 92, the average of the new list is 94. That's how I know number 30 is H. Okay, think about it like this. 8 more is being added to the second list, okay? Another way to do that would be to make this, let's just pretend these are all 100. I don't know what they are, okay? But let's just pretend they're all 100. That would mean that if the first list has 100, 100, 100, then we could think about this bottom list as being like 102, 102, 102, and 42. Okay, that would be another way to write that. It's just 2 per number, because 8 total is being added to the list. If that's 2 per number, that's an average raise of 2 per number. And that's how I know number 30 is H94, because the original list says 92. 2 per number more is an average of H94. Number 31, the vector I represents 1 mile per hour east, and the vector J represents 1 mile per hour north. Maria is jogging south at 12 miles per hour. One of the following vectors represents Maria's velocity in miles per hour. Which one? Well, you don't have to know what a vector even is, really, to get this question right. What we need to know is that J represents 1 mile per hour north. I guess I can draw an up arrow for north or something. And this girl, Maria, is jogging south, or the opposite of north, at 12 miles per hour. So if J is 1 mile per hour north, then negative J is south. Okay, or negative 1J would be negative 1, or be 1 mile per hour south. Negative 1J, which is negative north, is south. So all we have to do is make this, well, 12 miles per hour, negative J, that'd be negative 12J. You see? And that's why 31 is B. Number 32. 4 identical glasses are shown below. 1 glass is empty, and the other 3 glasses are a quarter full, half full, and 4/5 full of water, respectively. If the water were redistributed equally among the 4 glasses, what fractional part of each glass would be filled? So if I were to give this problem to students, say in maybe pre-algebra or something like that, I would not have any answer choice options, F, G, H, J, K. They would just have to figure it out without a calculator, and what I would expect them to do is to find a common denominator between these 4 glasses, to add them up, to maybe simplify and then divide by 4, because really what we're looking for here is an average. Like, what's the average amount of water in the 4 glasses would be another way to rephrase this question. But the fastest way that I can think of to answer this question would be to simply put this in my calculator. Now, when you do it in a calculator, you're going to be working with decimals, not fractions, but that's okay. So let me show you what I mean. I'm going to write out what I would type in a calculator. I probably wouldn't even write anything down on this piece of paper if I were doing this in real time in the ACT, but here's what I would type in my calculator. So I'm looking for the average of these 4 glasses. So I'm going to need to add up how much water they have and divide it by 4. So there's 0 water in the first one, plus we're told the second one is a quarter full. Well, that's 0.25, right? Plus the third one is half full, so that's plus 0.5. The last one is 4/5 full, so that's plus 0.8. And I would divide that whole thing. Come on, line, where are you at? Something going on here. Okay, you get the idea. Divide that whole thing by 4, and that's going to give me the average amount of water in each glass. So when I type that in my calculator, that ends up equaling 0.3875. Okay, in other words, they would all be like 38.75% full. So what I need to do with this, obviously, none of these is the right answer choice. Like you don't see 0.3875 in any of these answers, but I would need to go through the answers one at a time and put them in my calculator and see if I can find the right decimal. So for example, F, 2 divided by 11 in my calculator is 0.18, so it's not F. G is going to be way too big, right? I can already tell that's way bigger than 0.3875. H is going to be way too small, but I'll do it anyway. 3 divided by 22, that's 0.13. J, 31 divided by 60 is 0.5, so it's over half full. That's not right either. Try K, 31 divided by 80, and sure enough, it's 0.3875. And that's how I know number 32 is K. Number 33, Aurelio is purchasing carpet tiles to cover an area of his living room floor that is 8 1/3 feet wide by 10 feet long. Each carpet tile is a square 20 inches wide by 20 inches long. What is the minimum number of carpet tiles that Aurelio must purchase to cover this area of his living room floor? Now, I wish there was some kind of just easy equation that you would plug these numbers into in your calculator or something, and poof, it would just spit out the right answer. But there's not. And the ACT loves this kind of question where you have to go from like feet to square yards to yards, or in this case, feet and inches, and you're dealing with, different measurements and things, and you have to convert from one to another. So if these carpet tile squares are 20 inches wide by 20 inches long, to figure out how many of them that I'm going to need in this floor to cover this floor, the first thing I'm going to do is I'm going to convert each of these dimensions here to inches, okay? So 8 1/3 feet, 8 times 12 is 96 inches, plus the 1/3 feet would be another 4 inches. So I'm just going to draw this out, I guess. So it's 100 inches, what does it say, wide, okay? Then it's 10 feet long. Well, 10 feet, 10 times 12 inches is 120 inches wide or whatever, okay? And actually this kind of makes it a little simple to figure out how many carpet squares I need, because I can pretty easily figure out how many I need in this direction and how many I need in this direction, because we're dealing with 100 and 120, and both of those are divisible by 20, So going down, if these carpet squares are 20 inches wide, we said this is wide, then I would need 5 in this direction, right? And going by the length or long, we know they're 20 inches long. Well, if this floor is 120 inches long, then I need 6 of them lengthwise. So 5 down or 5 width, 6 with the length, 5 times 6 equals 30. And that's how I know I need D, 30 of these carpet squares. Number 34, in the standard XY coordinate plane, a circle with its center at 8,5 and a radius of 9 coordinate units has which of the following equations? So if you can't quite remember the formula for the equation of a circle, you're just going to have to make your best guess. There's no point here in spending minutes on this question trying to figure it out. There might be a way to graph it in a graphing calculator or something, but you don't have time to figure all that out right now, okay? So, even if you graphed it, you're going to have to be playing with all these different answer choices. This is going to take forever. So here's the formula for the equation of a circle. It's, whoops, I got the eraser on. X minus h squared plus y minus k squared equals the radius squared, where hk is the center of the circle. Okay, so they tell us that the circle has its center at 8,5. So we're looking for x minus 8, because h is 8, right? Because hk is the center, it's centered at 8,5. So x minus 8 plus y minus k, where k is the y coordinate of the center of the circle. So y minus 5, and these are both squared, is going to equal the radius squared. The radius here is 9, so 9 squared is 81. So x minus 8 squared plus y minus 5 squared equals 81. We just got to find it. And that is F, yes. So that's why 34 is F. Okay, use the following information to answer questions 35 to 38. Many humans carry the gene YQ77. The YQ test determines with 100% accuracy whether a human carries YQ77. If a YQ test result is positive, the human carries the YQ77 gene. If a YQ test result is negative, the human does not carry YQ77. Sam designed a less expensive test for YQ77 called the SAM77 test. It produces some incorrect results. To determine the accuracy of the SAM77 test, both tests were administered to 1,000 volunteers. The results below from this administration are summarized in the table below. So here's all the people who received a positive YQ test, a negative YQ test, a positive SAM test, and a negative SAM test. So here we go. 35. It costs $2,500 to administer each YQ test and $50 to administer each SAM 77 test. What was the total cost to administer both tests to all the volunteers? So one tricky thing about this little question here is that you might think, oh, I've got to correctly add up all these things in the table. But the question says both tests were administered to 1,000 volunteers. So 1,000 times the cost of the YQ test plus 1,000 times the cost of the SAM test is going to be our result there. So 1,000 times the cost of the YQ test, which is $2,500, plus 1,000 times the cost of the SAM test, which was, $50? And let's just put that in a calculator. So 1,000 times 2,500 plus 1,000 times 50, and I get $2,550,000 is the total cost, and that is answer choice E for 35. 36. What percent of volunteers actually carry YQ 77? So to actually figure out the accurate results of how many of them or what percent actually carry YQ 77, we have to look at the YQ tests, right? Because this is the one that is accurate. So the ones who are given a positive YQ test in total are 590 plus 25, because both of these groups got a positive test. So 590, let me erase these little arrows here. So 590 plus 25 is 615. Those are out of the 1,000 who had a positive result. The negative results are 10 plus 375, which is 385. And those should add up to 1,000 because 1,000 people got this test. So what percent of them actually carry this? Well, that would be the number who carry it, which is 615, divided by the total number tested, which we know is 1,000. So if you put that in your calculator or you just kind of think about it, you're going to see that this little fraction is going to be 0.615, which is 61.5%. And that's how number 36 is J, 61.5%. 37. For how many volunteers did the SAM 77 test give an incorrect result? So here we're not even looking for percentages. It's just asking us how many total people got an incorrect result. Well, if this is the column of people that definitely have a positive test, well, look, this many people, the 25, got a negative SAM one. Okay, so that's wrong. So it's 25 plus, if this is the column of people who definitely got a negative test, well, these 10 people got a positive one, so that's also wrong. So 25 plus 10 equals 35, and that's why I know 37 is C. 35 people. 38. One of the volunteers whose SAM 77 test result was positive, I need to erase all this junk up here to let us see what we're working with. So one of the volunteers whose SAM 77 test result was positive, so that's these people, just going to kind of circle it, will be chosen at random. Okay, to the nearest 0.001, what is the probability the chosen volunteer does not possess YQ 77? Okay, well, we know that 10 out of these 600 people actually don't have YQ 77. So in a positive SAM 77 test, 590 of them are going to be correct because they're also in that positive YQ column, but 10 of them are going to be incorrect. So the question is saying to the nearest 0.001 is the probability that this person doesn't actually have it. So that would be the total number who doesn't have it, which is 10, and we divide that by the total number of people tested, which is 600. I would imagine that a simple mistake on this question would be something like 10 divided by 590, but we can't just do the wrong ones over the right ones. It's the wrong ones, which is 10, over the total number tested. So if you go to your calculator, 10 divided by 600 equals 0.017. That's what you get when you round it. Looking back at my calculator, and that's under 38 is F, 0.017. Number 39. Given matrices X equals -1, 0, and Y equals -2, -1, which of the following matrices is XY? Okay, well, what's kind of fortunate about this question actually is that you don't have to figure out probably the most difficult thing in multiplying matrices for students that I've seen on ACT tests before, which is, am I even allowed to multiply these two matrices? Because just because you have two matrices, it doesn't mean you can multiply them. So I have a lesson on this in my book, The ACT Math System, about matrices, when you can multiply them, when you can't, that kind of a thing. It's not really math that you have to know, so you would find it in my book under the lessons called Good to Know, with practice there. But here we know that we can multiply them, and when you multiply matrices, you have to find what's called their dot product. So with these two little matrices, we have one row and one column. You take the first term in the first row, multiply it by the first term in the second column, and then the second term in the first row, multiply by the second term in the second column, and add them. So let me show you what this looks like. So we need to find -1 times -2. Whoops, not dot dot. I put a colon there, sorry. -1 times -2 plus 0 times -1. That equals, well, 2 plus 0, which equals 2, or, whoops, with the brackets for matrices, just 2. That's how number 39 is D, 2. Number 40, regardless of how the graph is oriented in the standard XY coordinate plane, no graph in one of the following categories has a vertical line of symmetry. Which one? Line, square, pentagon, parallelogram, scalene triangle. What this is saying is that if it's graphed or whatever, if we take a vertical line like this and we play with these shapes over here and we twist them, you know, we make them go left and right and we mess with them, this is saying which one of these 5, it's not possible for this shape to have a vertical line of symmetry. Okay, well, let's look at F. Think about a line. You know, a line's going to go like this, right, or whatever. Well, it's going to be symmetrical. Okay, so it's not going to be a line. Whoops, so forget that one. Okay, let's look at the second one, which is a square. Well, I think you can probably see that if I draw a square on here, sorry, that's more like a rectangle, but if I draw a square on here, it's going to be symmetrical if I draw a line straight down the middle. You know, it's going to be half on the left, half on the right. So it's not a square either. A pentagon, same thing. You know, if I draw a pentagon, probably not, I'm not going to draw it very well, but, you know, you can probably get the general idea, whatever. If I draw a pentagon, it's going to be the same on the left and the right, so it's not going to be that one either. That leaves me with a parallelogram. And a parallelogram is just a shape whose opposite sides are equal in length and parallel. So usually when we work with parallelograms on the ACT, you're dealing with shapes that look like this. You know, what is going on with this thing? You're dealing with shapes that look like that, where they're kind of leaning, and that would not have a vertical axis of symmetry. However, guess what else is a parallelogram? A square. Again, we already dealt with the square, because the square has two parallel sides or whatever, and they're all the same length. So it's not J either. That's why the answer is K, a scalene triangle. A scalene triangle, I think we talked about this with a previous question, and it's kind of unusual for this term to show up twice on the same ACT. But a scalene triangle is a triangle with 3 sides that are not the same length. So if I just made up a triangle like this, that, or something, and this is like 6, 7, and whatever that would be, like something like that is a scalene triangle, and there's no way to have a vertical axis of symmetry with an oddball shape like that. And that's how I know number 40 is K, a scalene triangle. Okay, guys, that does it for numbers 21 through 40. Next time we'll do 41 through 60. If you want to get better at the ACT math that's required for every single test, and then the math that's required for most tests, and on, kind of in order of importance, then check out my book, The ACT Math System. Thanks, guys.